And this is just one of my kind of things I do. I do a lot of talks to the technical audience. This is my first time I'm giving a talk to a non-technical audience, so hopefully I don't put anyone to sleep. But I tend to always kind of have the martial arts higher human needs in my talk. The bottom part there is about human ingenuity. This is the substrate that helps us dominate, human ingenuity. On top of that, I mentioned the earlier the writing system. This allows us to persist knowledge across space and time, so that future generations, past generations, can pull upon knowledge from the ancestors. Next is the mass printing. We just talked about that in Gutenberg. And then after that, and you can see the timelines between each of these phases is getting shorter and shorter. Technology is growing at a more and more rapid pace each time. In the 1970s, that's when personal computers came about. So you think about Microsoft, you think about Mac, those came around in the 1970s. On top of that, in the 1989, Tim Berners-Lee created the internet. And this is back in what life was like before the internet. If you wanted to know something, you couldn't just go search for it. You actually had to go to a library, get an encyclopedia, and read about it. If the encyclopedia wasn't there or out of date, you're kind of out of luck, unless you have your own personal alignment GPT. And wait, y'all don't know what alignment GPT is? My sister's alignment GPT. This is my alignment GPT here. When we were younger, if I didn't know something, especially when it comes to personal trivia, I just ask her, and she'll give the answer. So if alignment GPT didn't know it, you just have to live without knowing. And this is something in film that we don't really deal with nowadays. We don't deal with not knowing anymore. If we don't know something, we just look it up. Back then, if you didn't know, you just had to live with it. After that, there was the internet, but the information was not organized. So in 1990s, search engines were built. You had Alta Vista, you had Yahoo. All the search engines started getting built. Google was created in 1998. So search engines came, and after that came the modern cloud. This is also something that's very underrated. Back when I was doing my PhD, we didn't have the cloud yet. It just started coming to be as I was getting my PhD. Before that, it was financially feasible to do certain types of research because you had to put the financial investment up front to buy all the computers that's necessary. And we're talking about millions of dollars. And in today's world, sometimes when we talk about training large language models, you need sometimes billions of dollars. You need sometimes to build a data center. So we're talking about billions of dollars before you can even start. So we're just financially infeasible without a cloud. So without the cloud, a lot of things we have today would not have been created. And next in 2007, well, smartphones were created before 2007, but in 2007 is when the iPhone was released. And this was when everybody started getting phones. The iPhone was released in 2007, and then Android came shortly after that. So what this means is that now everyone in this room has a computer inside your pocket or your purses. And what is allowed now is for anybody now to have access to information at your fingertips. And the last one again there, the symbol, that's the pig for AI. I want to tell you a little story. So being the chief architect of my company, a lot of these sub-tech companies, they come and cater to us. Microsoft comes and caters to us, Google comes and caters to us because they want our business. But in a meeting back in, I think it was 2014, I was trying to get my company onto the cloud. So I had a meeting, I brought Microsoft in, and we're talking about the cloud. The cloud is called Azure. So they were presenting to me and showing me and my colleagues and my boss was in the room at the time. They were presenting to me at the time and they said, they were trying to brag about how big the data center footprint is. They said, we have data centers in all of the continents. And I was like, really? And I was like, but where's Africa? At that point, this is a newer diagram here. So back then, in 2016, South Africa didn't have a data center. So all of Africa was the only livable continent that didn't have a data center, which means that Africa couldn't control its own destiny when it comes to technology. Since 2023, I think a few cloud companies, they put some data centers in South Africa now. So that's a good thing. And when I asked the gentleman, why don't we have any data centers in Africa, he said there's no demand for it. It's not going to be financially feasible. So, but fortunately, that is happening now. And just one of the fun facts. Below the southern hemisphere, no country has nuclear weapons. So Africa doesn't have any nuclear weapons, South America doesn't, Australia doesn't have any nuclear weapons. But one interesting thing is that South Africa did have a nuclear program, and they were pretty advanced in the nuclear program. And they're the only country in history that willingly turned over their nuclear program. And can anyone guess why that happened? After apartheid? Yeah. 1991, the power was about to change. The political power was about to change. Apartheid was ended, the power was going to go to the indigenous crew. And because of that, they got rid of it. They didn't want the weapons in the hands of the opposition at the time. So just a little fun fact. So let's talk about artificial intelligence. So there's a lot of confusion about artificial intelligence. There's a lot of misnomers using the wrong terms to mean different things. So this is where I just want to kind of help demystify and help clarify some of these terms. First term, artificial intelligence. In layman's terms, very simple thing. Artificial intelligence is just a simulation of human intelligence in machines. That's all it is. It's a big field, and there are many subfields under it. One of those subfields under it is machine learning. So machine learning is not, or I say AI is not only about machine learning. Machine learning is a subset of AI. And machine learning is essentially using data to train machines to do things like human beings. For example, giving machines a lot of examples, and based on those examples, the machine is able to classify things, classify images, or make predictions. That is what machine learning is. Neural networks is a type of machine learning. It's a subset of machine learning, but it uses the brain-inspired algorithms. So in the body, the human brain, and the central nervous system, we have neurons, we have central nervous system, and neural network uses that kind of topology, that kind of architecture to build a machine learning system. Deep learning is just another subset of neural network. It's essentially a bigger neural network. So when you're hearing things about like ChatGPT, when you're hearing about large language models, those are using deep learning. And the other thing I wanted to, this is a bit small in the graph, but another thing I just want to show here, just to kind of help stop some of this myth and some of this hype about AI, is that right now a lot of people think that our ChatGPT, these things are AGI, artificial general intelligence. But that's what a lot of people think that. But ChatGPT is not AGI. It is artificial narrow intelligence, which is a step below AGI. So we don't have AGI. AGI is right now completely theoretical. ASI, artificial superintelligence, is completely theoretical. And many experts don't think we're going to get that. At least we're not going to get that for years, maybe even much longer. We don't know yet whether it's possible to build a system that is truly AGI, not to mention ASI. So when you hear Sam Altman or a lot of people try to sell you on AGI, it's not here right now. It's premature. One day we might get there. A lot of smart people are trying to put a lot of money behind this, but we're not there right now. I debated whether I should put this into the chart because this might get a little technical, it might get a little deep, but I'm going to try to explain it. So what I have here is a neural network. So we have a neural network on the left side. I'm going to try to explain the way this works. So with a neural network, you have essentially three categories of layers. You have your input layer, you have your hidden layer, and you have your output layer. The input layer is where the data comes in. So say you're trying to classify an image. You're going to take every single pixel of that image, and it's going to go through that input layer. So say you want to classify numbers. You want to categorize numbers. You have handwritten numbers. Say you're on a 10 by 10 pixel. So they're going to be, if it's 10 by 10, you're going to have 100 nodes on the input layer to be able to take in every single pixel. And then on the output layer, if you're trying to kind of classify digits, numbers, you're going to have 10 different nodes, 10 different neurons. A number 2. You're trying to categorize a number 2. So in order to train this, and let me back up a little bit. When you talk about training, you get a lot of data. We're talking about millions of data points in the data set. And what you're going to do there is that you're going to maybe reserve about 80% to do the training, about 20% to do the validation, the testing on your model after you train it. So you're going to get 80% of your data set, feed it through the input layer, and initially all of these lines are called weights, parameters. So when you hear all these companies bragging about how big the large language model is, they're really bragging about how many lines there are in the system. This is how many weights are in the system. The more weights you have, the more neurons, and technically we call them perceptrons. The more perceptrons you have in your neural network, the stronger your neural network is, the more complex problems your neural network can solve. So initially, all these weights are set to random numbers. And as you start training, so let's walk through an example. You have a number 2. You put it through the network, it gets a 2. Then when it comes to the output layer, the first time, because it's random, it doesn't categorize it as a 2. You're going to say, okay, this is a 9. And then this is where we have algorithms called like backwards propagation, gradient descent. You're going to say, oh, that was wrong. Now we're going to push everything back to the neural network backwards, and then we're going to try to reduce the loss. And loss is actually the error margin in the network. So we're going to say, okay, because it was wrong, all of the weights in here, they're going to change based on how far they are from the correct value. And that happens not just one time, not 2 times, not 3 times. This happens billions of times where you go back and forth, pushing the information in, they're using backwards propagation and gradient descent to get those weights to get to a more real number. So I want to use maybe a more realistic example, an analogy to kind of explain this. Right now, my daughter wants a dog. So I've been researching puppies. So when you get a puppy, first of all, it is not potty trained. So what happens is that you bring the puppy into the house, it pees on the floor in the living room. And you chastise the dog, you say, bad dog, bad puppy. You pee on the living room, you can't do that. So next time the dog's gonna say, oh, okay, I can't pee on the living room. Next time it goes and pees in the kitchen. And you say the same thing, chastise the dog, bad puppy, don't pee in the living room, don't pee in the kitchen. So you start thinking, okay, wait a minute, I get it now. I can't pee anywhere downstairs. I can go pee upstairs in the bedroom. You see pee on the bedroom floor upstairs, you chastise it again, say, bad dog, you can't pee anywhere in the house. And after a while, maybe after about 2 weeks, a month, it starts to kind of get it. The dog's internal neural network starts to form these connections to realize that when I'm peeing inside the house, I get chastised. When I'm outside and I pee outside, I get a treat, and they tell me, oh, good boy, good dog. So over time, you've trained the dog what you want, desired behavior, from behavior that's not desired. So that's analogous to what we're doing here with a neural network. We essentially, when it gets the wrong answer, we chastise the neural network and say, do better. And over time, it does better. And here, what we have here is the deep neural network. So essentially, you see the deep neural network looks very similar to the regular neural network, except that we have more hidden layers. And the more hidden layers you have, the more complex problems you can solve, like I mentioned earlier. So when we're talking about the size of the network, I just want to kind of give you guys the scale we're talking about. So when GPT-1 came around, and GPT-1 wasn't really available to the public, I didn't get to use GPT-1. I got to use GPT-2 because I was in an early access program. And let me say, GPT-2 wasn't that good. It wasn't really that impressive. So even myself, I was surprised when GPT-3 came out and ChatGPT came out, and just impressed with how amazing it was, because the models before that were nowhere near that good. So GPT-1, it had a little over 1 million parameters. GPT-2 had about 175 million parameters. And as I said, like I mentioned, it wasn't that good. GPT-3, the one that ChatGPT, what you all first saw back in November of 2022, that had 200 billion parameters, or 200 million parameters. Let me get that correct. GPT-4, the one that is not the most recent model now is GPT-5, that's a frontier model. But GPT-4 had, and now OpenAI is kind of keeping these close to the vest, so they're not publicizing these numbers. But people estimate that GPT-4 has about 2 trillion parameters. And the thing about these numbers, I think it doesn't sound real to many people. Most people don't really get the scale of these numbers. And let me just say, if you put this in terms of time, I think it makes it a little bit easier to realize how big a trillion parameters are, how big 2 trillion parameters are. So if I was to give you 1 million seconds, that equates to about 11 days. If I was to give you 1 billion seconds, that equates to about 34 years. If I was to give you 1 trillion seconds, want to guess how big that is? How many years?
2 million.
Is that another point? That's a lot. But it's 34,000 years.
Like years.
34,000 years, that's how big it is. So the difference between a million, 11 days, to a trillion, 34,000 years, bigger than the entire history of mankind. That is the difference. So when we're talking about these models nowadays, these models are humongous. And I just want to stress this a little bit more. These models, the amount of energy to power to build or train a model like GPT-5 or GPT-4, it'll power the city of San Francisco for several days. The amount of energy that's used in San Francisco for several days, that's how much energy it takes to train these models. 6,000 homes. The amount of energy it takes to power 6,000 homes in 1 year, that's how much it takes to train these models. It takes a lot of energy, it takes a lot of time, and it takes supercomputers, big cloud data centers in order to get this done. So I was talking to my son the other day, and I was asking him, how do kids in the school use GPT, or ChatGPT, Gemini, all the different LLMs out there? I said, well, they really use it in 2 ways, is what he said. He said the first way they use it, a small fragment of the students use it to learn. Most of the students use it to get the answers, aka to cheat. That's what a lot of people are doing with ChatGPT. So what I want to go, when I'm talking about a thin line between love and hate, the love part there is using ChatGPT to help you learn. You don't want to just take from these like machine models. You cheat yourself when you do that. The hate part is when you're using ChatGPT just to give you the answers. If a student is using ChatGPT just to get all the answers, you're not learning. So this is very interesting. I'm fortunate that OpenAI just actually released this research last week. It came out on the 15th. And this research, it was talking about how people use AI. So everything you guys put into AI, ChatGPT stores, and you're able to produce all these statistics on. Most of what people are using it for is for practical guidance. So 28% is people using the LLMs, the large generative AI, for practical guidance. So that's pretty good. Using it for practical guidance is a good thing. The second thing people are using it for is to seek information. So essentially, this is kind of turned into a search tool. Right now, a lot of people, when you go into Google now, a lot of people, they don't really even look at the results anymore. The first result, that's from Gemini. It's a large language model, and usually people just use that, and they don't go any further. They just get the answers from what Gemini says is very tough. Next, now this one's a bit worrying here. The next thing people use it for, the next highest thing people use it for is writing. So a lot of the writing you're seeing now, a lot of the writing getting created nowadays, it's not writing made by human beings. It's actually writing that the AI is generating. And then following on behind that, we have multimedia, self-expression. But the key things I just want to pull out of here, that the one I'm worried about is a lot of the writing we're seeing is quote-unquote AI slop. There's a lot of things being generated that is not really coming from the human. And this is another chart that OpenAI released last week. So what they're trying to do, they try to break down the different tasks about whether you were trying to ask the AI how to do something, which is this kind of healthy back and forth with the AI, where you're kind of asking the questions, trying to learn, or how much you're asking AI to actually do something for you. This is when sometimes it's good to just say, okay, AI, go do this for me. But a lot of times, you don't want to be solely reliant on outsourcing your brain to the AI. If you don't use your brain, you're going to start losing your mental acumen over time. So when it comes to seeking information, this kind of makes sense. A lot of people are using AI, they're asking AI questions, they're not necessarily asking AI to do things, but they're seeking information. When it comes to practical guidance, they're asking AI most of the time what to do, they're not necessarily asking them to do something. But when it comes to writing, They actually tell the AI, go do this for me, go write this email for me, go write this story for me, go write this book for me. That's what people love people using AI for. And it's more than just benign, tell the AI, go write me this email that I don't want to write. Some of it is actually malicious now. Now we're having Yahoo boys. Yahoo boys now have a PhD in scamming because now they can go to the AI and have the AI write something that's very well crafted. And when I'm saying about Yahoo boys, keep in mind, Yahoo boys, people talk about Yahoo boys, that was a Nigerian thing. That's old. I don't know, the stereotype stuck with us. It stuck with Nigerians, but that's old. When we talk about Yahoo boys, the big boys now are people in, I don't want to call our countries now, but the other countries right now that are scamming people in other countries. I'll name one country, because I think it's in the news quite a bit now, like Russia. Russia has been using espionage to attack many companies and commit cybercrime. So, and a lot of that is being powered by AI. Back in the days, we have something called Patch Tuesdays, where every Tuesday or every few Tuesdays, Microsoft and many companies will release patches to vulnerabilities. Before AI, it would take an attacker, a cyber criminal, many months to be able to reverse engineer that patch to figure out how to exploit it and start looking for machines that aren't even patched yet and try to exploit them. It used to take months. Now, it takes days, sometimes hours, all because of AI. They're able to write code, reverse engineer a patch, write code, and be able to exploit systems in days. Remember, this is kind of more of the same, just people using AI in ways that shouldn't be used. So just a few more things I want to talk about. Just some things to consider when you're using generative AI. The first, generative AI is not necessarily interested in the truth. It's interested in what is probable. Sometimes, and a lot of times, that aligns. But many times it does not align, so you have to be very, very careful. There's a thing called hallucinations, and hallucinations is when, sometimes people call it, oh, the AI lied. The AI doesn't know how to lie, it just gives you what is probable. A hallucination is when it gives you something that is incorrect. Another thing is the cost. It costs a lot of money to train these models, and eventually, at some point in time, VCs are going to need to recoup your money back, and when they want to recoup your money back, a lot of the services that are currently not free, a lot of the services that we're paying for, a lot of the generative AI services we're paying for, they're going to start costing a lot more money. It outweighs with the amount of the kind of technology we have nowadays to train these machines. This is the big one here, data privacy. Anything you put into ChatGPT, especially if you're using the free version, anything you put in there, the company has they're able to use that to fine-tune and train the model. So if you put any sensitive information there, you need to be very careful. Because now, next time somebody asks, oh, what is this person's SSN, social security number? If you put your social security number for whatever reason into this model, it can be trained on that. So just be careful what you put in there. Whatever you put into these models, whatever you put into ChatGPT, it is not a secret. They can use it to train the model, so just be careful with that. Same thing goes for intellectual property. If you have some kind of information, some kind of intellectual property that you want to keep close to your vest and don't want to get out, you just be careful putting it into ChatGPT because, as I mentioned, that information is not private. So this is where I want some audience participation. As I mentioned, these technologies are very, very, very good at producing images. They're getting very, very good at producing audio, getting extremely good at producing video. And it's getting harder and harder to tell what is real and what is not real. And I want to give everybody in this room to be on and be able to tell what is real versus what is not real. So we're going to go through an exercise. So first one, top left corner, I want a show of hands. Do you think this image is real or not real? So first of all, if you think it's real, raise your hands. So we have one, raise them high so I can see it. Okay, a few people? Okay, now, who thinks it's not real? Raise your hands. Okay, I need more participation in this. Raise your hands if you think it's not real. Okay, that's the majority. Most people think it's not real. And we're not coming up to a good start right now. This picture is real.
Real.
Kudos to the 4 people that raised your hands for it, but most people got it wrong. The second picture, top right corner. Real or AI? Okay, raise your hands if you think it's real.
The two of them are the same.
3 people? 4? Who thinks it's not real? Raise your hands.
I'm gonna go no.
Okay, that's the majority. I think we're learning here. We're getting better. You're right. This is AI generated. Okay. Bottom left corner. Raise your hand if you think it's real or not real. Real. Say about roughly about 8, 10 more people. 8 people. Okay. Who thinks it's not real? Raise your hands. I need some participation here. I think the majority of people think it's real. The majority is saying real. It is not real. It's AI generated.
It's not real. I said it's not real.
You said it, but most people said it was real. So you got it. Okay, the final one now. Real or not real? If you think it's real, raise your hands.
I think it's real.
2, 3, 4, 5, 6, 7, 8. Who thinks it's not real? Raise your hands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, you guys are doing good. It's not real.
Oh yeah.
So you guys got 50-50. That's not really a good percentage. So what I want to do is I want to kind of talk about how can you detect an image from real versus not real. This is tough.
I need that clarification.
Oh, wrap it. Okay. We need to wrap it up here. Okay, so tips for detecting AI photos. Detecting AI generated photos. I'm going to go quick here. First one, does the picture look too perfect? If it is, it's like chances are that is AI. People aren't perfect. 2, look for jumble or nonsensical tests. So when it comes to generating images, right now the current state of technology, when you generate images, the text doesn't look real. It might look like, it might resemble an English character, but it looks very jumbled. 3rd, check for, this is the one I use the most of the time, check for oddities in the fingers and hands. A lot of times you might see a person that has 6 or 7 fingers. You might see a random finger somewhere else where it shouldn't be. You might see one finger forward, another finger backwards. So look at the fingers. Look for realistic light and shadow. So you want to look, where's the light source in the picture? And sometimes you can see the shadow in the wrong place. So look for light sources. I'm being told I don't have much time, so I'm going to speed this up. You have to scrutinize the background for discrepancies. A lot of times the main subject, the AI focuses on that, but there's a lack of attention to detail when it comes to the background. So for the subject, the main subject looks good. The background, something is usually off of that. So look for that. Look at the background. Look for inconsistencies of jewelry, especially with women. If you see a picture of a woman, a lot of times you can see they have earrings. And sometimes the AI will get one earring right, but a different earring or no earring on the other side. And sometimes maybe some people might wear different earrings, but usually women keep the earrings looking the same on both sides. So look for the earrings, look for jewelry, look for accessories. This one, I can't really explain it, but a lot of times you have the soulless look in your eyes. It looks like there's nothing there. So look at the eyes and see whether it looks like there's really a soul behind those eyes. Do the hair strands look natural? Sometimes the hair just doesn't look real. And this is another one I look at a lot too. Sometimes the facial emotions don't match the context. Their eyes may be smiling. You know, people's eyes can smile. The eyes might be smiling, but the face is not smiling. So look for those kind of discrepancies. And if you're talking about something very serious, you want to start looking for, well, this one's different. A lot of companies now, when they produce these AI-generated images, they have AI watermarks in them. So look for the AI watermarks. There's some AI tools where we're using machine learning, AI, to detect whether things are AI. Look at using these tools. And then if it's something very serious, you can consult a digital forensic expert. So we're going to go through the exercise one more time again. And I'm going to cut it short here. This picture, how can you tell this picture's not real?
Oh, there's a finger. Yeah, the hand, the lady in orange.
This is a random finger sticking out here.
And look at that one, the red.
That's another one here, another random finger. Why is a finger here? And hands is down here, but there's a finger here. So you always look at the hand. The hand's a lot of time to give it away. And in the background, there's some things that just don't quite make sense in the background. And another thing, this is 2025. If you have a phone nowadays, the phone is going to have a camera in the back. It looks like you're maybe trying to take a selfie, but why is there no camera lens on the back? So just things like that can help you give it away. Same thing over here again. I actually had Gemini generate this image. How can you tell this is not real?
The
The
fingers.
fingers again. Look at that finger. Why is the finger normal size over here, and the finger over here is completely different? The boy's fingers, they completely different. You see one finger pointing forward and backward. That's it. He has a nail in the front and a nail in the back also. It just doesn't make any sense. It looks good on first glance. It looks good, but when you actually start scrutinizing it, you just see very small discrepancies. And what if this is just something, this is just the state of technology right now. It's going to get increasingly harder over time. So the things, like the tools I'm giving right now, they work today, they're probably going to work for the next few months, but the technology keeps getting better, so it's going to get harder and harder to tell this in the future. Videos. AI is able to produce videos. And what is this not playing? I think I'm going to end it on this one because I know we're short on time and I don't want to keep you all. So this is the video. This is AI generated. Will Smith eating spaghetti. Kind of look at the different clues of how you can tell this is not real. Look, Will Smith, yeah, he has an earring hole right there in his ear. There's the earring hole. It's bigger for some reason. Look at the different molds on his faces. Like sometimes it just disappears. There was a mold here earlier. It went away. Now there's one up here. The earring hole is gone now. You had the earring hole before. Now it doesn't have the earring hole anymore. But there's different things you can do. You have to scrutinize the pictures very well, to tell whether something AI done. But that's very impressive. In 2020, I don't have the time to show you what it looked like back then. But things have changed quite a bit since 2020. And I'm going to skip ahead since we're short on time. And I'm going to ask everyone in this room, you guys need to help and you need to be aware when it comes to spreading disinformation. So there's two things. Disinformation is willingly given bad information. The information you know is incorrect, willingly trying to pass it on and publish it as being incorrect. The second thing I think is a little bit more dangerous, and I think a lot of people accidentally do this, is where you engage in misinformation. If you think the information is correct, well, you can spend time to scrutinize the information. So social media is not a place for news. Social media is a place for fun. If you see something on social media, a lot of times it's disinformation, and you want to be careful to scrutinize things and before you spread it out. Don't forward something if it's fake. So do your research there, and I think that'll help the world become a better place. I'm out of time, so thank you all. It was a great time.
Good job.
Thank you.
Good job.